Welcome to the Motoring Podcast, a Bcomp Sustainable Lightweight Natural Fibres Composite Materials Special Edition. Hello, I'm Andrew, and I am delighted to be joined by Per Mårtenson, who is the CSO of Bcomp and will help explain the company, what they do on this episode. Thank you so much for joining me, Per.
Thank you for having me, Andrew.
Okay, before we get into what Bcomp is, I wonder if you could tell the listeners a bit about yourself, what you do at Bcomp, and how you came to join them.
Yeah, so very shortly, I've been working in the composite industry for, getting close to 20 years now, which scares me a bit. And the last 10 years, I was working as strategic expert for one of the bigger OEM groups in the automotive industry, focusing really on implementing composites and how to make cars lighter and more fuel efficient and so on. And 4 years ago, I was approached by Bcomp to take on the role as CSO for Bcomp, so focusing on business development, sales and strategies, how to go to market with their unique natural fiber solutions, and more or less like how to reduce plastic, reduce material use in the cars and make them more sustainable. And that was a challenge that was hard to say no to.
No, excellent. Thank you very much for doing that. And that sounds fascinating. 20 years in composites, my word. It's come a long way in that time.
Yeah, that's despite looking so young, yes.
I know. It's a shame for our audio-only audience that they don't get to see you in all your glory. But I'm not sure that many of the listeners will have heard of Bcomp. So I wondered if you could explain a bit about the company, what they do, because the brief investigation I've done into this, there's some really exciting products out there, and that's before any future developments. But what you've got now is really exciting. So if you could help our listeners understand sort of what the company is about, what it does, and what it's trying to do.
So Bcomp is a company focusing on high performance composite, but purely made out of natural fiber composite reinforcements. And these are actually fibers that are very interesting in terms of mechanical properties. You just need to develop solutions that are aimed for them and not trying to copy what is made out of carbon fiber or glass. And now we are introducing them into everything from sport and leisure, recreation, marine, luxury yachts, stepping into motorsport, where we are now racing in more than 18 racing series, including Formula One. And now taking a giant leap into the high volume automotive market with both exterior solutions and also thermoplastic interior solutions. And the whole aim of Bcomp, why we're doing this, is that we are challenging the industry to become more sustainable, using more circular materials. One of the major, most important points there is to dematerialize, so use as little material as possible in our vehicles and become as material efficient as possible. Mm-hmm. And then, of course, in the same lines, to use as little plastic in our future cars as possible. So that's Bcomp. And we have some patented IP-based solutions that helps us do this.
Mm-hmm. It's fascinating. I'm particularly interested in hearing you mention about the exterior panels as well, because when us muggles hear about composite panels, we obviously know about carbon fiber and we know about the strength in that. When you say natural fiber composite, what are you talking is the makeup of that? Is it several layers with some of the layers natural or all the layers natural? How does it work? Obviously, without revealing my piece.
No. So this is fairly official stuff, I will tell you. No, so using natural fibers in a smart way can make them extremely performant. And then we are very humble that natural fibers have very good potential when it comes to stiffness design parts, but everything that is stiffness and strength designed, carbon fiber, for example, will be much more efficient. However, in a car, and we talk quite roughly about like rain covers when we talk about body panels. Most of the body panels we have in a car is only there for showing the design, keeping rain out of the compartment or from the engines, and provide a very nice dent and flex and so on. And then, of course, in crash situations, not create any sharp debris and something that can create accidents or damage pedestrians and so on. And actually there we tick all the boxes. So thanks to our patented power rib solution, we can be as stiff in terms of bending stiffness as carbon fiber and as light. when it comes to thin monolithic layers. So typically in motorsport, we can replace, for example, on a GT4 car, we can replace all body panels with our system, and the car is still as performant. It is much safer to crash with, since we don't have any sharp shattering of the material. So we have actually much more plastic information in terms of our crash performance, and also thanks to our power solution, which is I try to explain it for your listeners. It's like a grid structure they have on the back of on the inside, on the B side of the body panel. It creates a bit like a catching net, so it actually holds the part together despite being crashed.
Oh, right. And so, just a quick question on the GT4 body panels, because I know that that's a problem for racing, that when the carbon fiber shatters, obviously it causes the sharp edges, which is a hazard for other vehicles then on the racetrack. I take it that isn't the same issue then with your panels, that doesn't happen. Is that right?
We completely take away that the problematic mechanism with carbon fiber. So when you crash here, you have something that in most cases stays even intact in terms of you have a buckle, you have like a really big crash. The parts is not thrown all over the racetrack, and actually the parts are the edges where you crack up. It's actually, you can even touch it with the hands, and it doesn't create any punctures and so on. It actually allows for much tougher racing, and it allows for racing to not be interrupted and so on. It's a very unique solution that we now also bring in to high volume and road cars, so to say.
I was going to say the marshals would love it that they don't have to sweep up as much.
So no, but that's clear. That's clearly a problem.
Yeah,
that's clearly a problem. And typically the parts afterwards can be both recycled or incinerated, and you recuperate all the energy. Very like sustainable and circular, in the sense that instead of just putting them on a landfill outside somewhere.
Yeah, absolutely. So when you say natural fibers, what are we talking here? What are the natural fibers? Where are they from?
So natural fibers is not something new for composites. It's been used for just like nobody have really not taken the high quality approach as we have done. So we have done quite a lot of work in terms of making it like automotive quality ready, so to say. The natural fibers we use for the moment is flax fibers based on the mechanical performance is the best with those, and also it's the best tracked fiber in terms of just sustainability aspects and LCA aspects. So we know exactly where it's grown in Europe and Belgium. Belgium and France are I think they supply more or less 80% of the world's flax fibers.
Right.
And it's actually the same fibers as you produce the linen clothing from.
Oh, right. Okay.
Yeah, we just treat it in a different way, so to say, to make it a performance composite instead. Then actually our IPs and so covers everything, all natural fibers. So the ambition to have a global footprint later on will lead us to having our solutions and our products of hemp fibers, for example, in the United States, and of other fibers in China and Asia and so on.
Nice.
To make it really as sustainable as possible.
Yeah, I can imagine. So how was this discovered? I mean, for Bcomp, was this like a happy accident, or was this a hypothesis that was sort of experimented on and then that was borne out? I mean, how? Because to me, being a mere mortal, this sounds like witchcraft to get this all together and make it work and understand that it is going to work for starters.
It all started actually 10 years ago now. So where the founders were developing the world's lightest ski course. So, I mean, we're based in Switzerland. The mountains are close to our heart. We spend as much time as possible out there. We want as performance materials as possible when we are out there. So they developed the world's lightest ski core. And then they actually used flax fibers as a composite layer between balsa wood layers. Everybody here worked with composite more or less from the start and have education in composite started to understand that this material actually have a very, very high potential to become a high performance material if you use it in the right way. And then our CTO developed these patented power ribs that is more or less like a way to mimic the veins on a leaf. So you can think about the leaf that has a very thin monolithic structure, and then you have the veins creating the bending stiffness and the stiffness of the leaf on the back.
Mm-hmm.
So they developed that and developed both a thermoset solution for exterior and the thermoplastic solutions for interiors. And said like this, we just have to go to market with and try to revolutionize the mobility sector. And that was roughly when they called me also.
Because I would imagine there's obviously you require different properties for internal and external applications. So where on the, say for the automotive sector, it's being used internally, you say, where roughly is that? Is that like dashboards? Is it door panels? What's the sort of thing it's used on?
So correct. Typically all flat to larger structures that you today need either very thick injection molded plastic parts or they use very thick non-woven natural fibers to compression mold. There we can use a very thin layer of non-woven with the powders on the back, and you compression mold it, and then you cover it with leather or Alcantara or TPO or whatever kind of covering material you would like for your interior design.
Mm-hmm.
And now actually based on collaborations with OEMs like Polestar, which are very vocal about their sustainability ambitions, we have also now developed like an aesthetic surface also. That they have shown on their show car, the Precept.
Mm-hmm.
So we have developed a unique look for them that is also as sustainable and performant to really boost and take us as much material as possible from the car.
Well, that must help them as manufacturers as well, because they're not having to do a second application. So you're giving the structural integrity and the finish in one, rather than it having to be structural integrity and a finish of whatever that somebody wants to slap on top of it. But that must, again, this is something I don't think many of us really appreciate, but to make the manufacturing more efficient obviously helps with the carbon footprint as well, because we're spending less time, less materials, etc.
That's an extremely good point, Andrew. I mean, you can imagine when you do something that you cover later on with leather, then you have everything from the thin adhesive film that you need to put on to glue it to the substrate. You have quite often some thin foams to make it this kind of semi-soft touch feeling and everything like that. And instead now we are providing what they call mono material solution, which is the substrate, the backing with all the attachment points and also the aesthetic surface is all the same material. So it's a PP and natural fibers, but you can actually just mill down and use in injection molding or whatever afterwards.
Mm-hmm.
So without any secondary steps and so on. Also in the process, as you say, there's no secondary step that you need to cover it with another material that you later on needs to separate to be able to recycle it.
Where are they being, or your panels being used externally in the automotive sector? Whereabouts, sort of on the vehicles themselves, are they typically being used at the present?
As I said, we aim for everything that is purely stiffness designed, because that's where we make sense to use. So hoods, fenders, roof, rear wings, front splitter, bumpers, everything like that. So, okay. And then it's depending on which OEM we work with, how extensively they use it. But more or less, they can replace all these parts that are normally carbon fiber, glass fiber. They can replace them with our Amplitex and the power ribs.
I'm presuming that cost-wise, it's very comparable to the likes of, say, carbon fiber or glass fiber or whatever other composite materials they perhaps wished to be using in the same areas.
So I would say like this, purely material cost, I mean, glass fiber is unbeatable.
Mm-hmm.
And then on the other side of the spectrum is carbon fiber. We end up somewhere in between. And then actually all these kind of very labor intensive parts being produced, they are so heavily labor cost intensive. So in the end, the final part price might not be as different. But there's quite some interesting secondary effects that you can actually. Our material solutions are actually certified, so you can actually throw them in the waste or even sell them to energy recuperation stations.
All right.
Which, if you want to post carbon fiber, for example, or glass fiber, you need to even pay firms to take care of it for you because you are not allowed to throw it like you want. So there's some very interesting mechanism that you could use there.
Again, that's all part of the carbon footprint and the impact on the environment, lessening those materials even more that you're producing in those panels, because they do have a secondary use down the line. If somebody isn't recycling them, they're using them for that. Okay, that's really interesting. That's something I hadn't appreciated before. But it's all sort of.
But actually, Yes, correct. And the big impact is really how we take a fiber that is grown out there that is actually capturing CO2 during the growth, while, for example, producing carbon fiber demands a huge amount of energy to produce a carbon fiber. And then you need the polymer that is the base for carbon fiber. So I think on a carbon fiber roof or a body panel, we decrease the CO2 footprint by up to 85%, even if we're using exactly the same epoxy system.
Wow, crikey, that's a lot. So you mentioned that it's
that's a lot.
Used in marine areas. I know this is about cars, but I'm fascinated. So whereabouts is it used in the marine? It's just personal inquiry now. Whereabouts is it used in marine applications then? Is it like the hulls? Is it parts of the ship? What are we talking?
So that was something that we initially thought we would never have a good product fit. But then a collaboration partner built a complete flat sailboat out of this, the complete hull, and so it looks beautiful actually, green boat in Germany. So we started to investigate it more and more. So actually our fibers now are being starting to be used in small dinghies and so on, which is amazing way to reduce the waste in all the marine yards and so on. And then, I mean, the flagship for us is the collaboration with Baltic Yachts, where they have built a 68-foot racer, I think the name is, which is 50% our materials in combination with carbon fiber. And it's amazing, like beautiful, both interior and exterior hull, everything is made out of our materials.
Is it pleasing, just this is a slight side note here, but is it pleasing when you are going around and you see your product in use, sort of out there in the world, you go, that's mine, that's a bit of my stuff?
No, but of course, when I bring out my surfboard made out of our materials, I'm quite a happy guy. But for several reasons.
Yes.
No, but of course, I would say pleasing, yes. Proud even more, I say, with the whole team and the whole company, that we are, even if we take baby steps, we are trying to change the world in some way to the better. So of course it's a very we're pleased when we see that, yes, but we don't stop there by at pleased, so we're going to continue to push this.
Well, that leads me on to my next question then. So what are the ideas for the future then? Where do you think this can go? Where is there no limit sort of thing to this? I mean, can we see it in aircraft, for example? Can we see it? I mean, I see. The problem is, I'm still blown away by what you do now. So I've only got to that stage, so I can't even think onwards of where else it could go.
No, but without exposing too much of our plans and what we're doing. I mean, clearly, the next step, very clear on motorsport, where we do exterior. The next step is really the road homologated luxury cars and everything like that. When we're starting to show that this is a performance material, and the customers will start pushing this, and the OEM will understand that we have to change our way we have to change our industry. So that is clearly the next step. The slightly higher volumes on exterior. Then we are going into high volume production of interiors. Hopefully, first production starts next year. So that we're going to grow and reach out to more and more OEMs and develop this to really reduce as much plastic as possible from our future interiors. And then, of course, the ones that you mentioned, aircraft and private jets and everything like that, we will never target primary structures, of course, based on just the performance of the material. But there is interiors in those also, which are very weight sensitive, where actually the value of it is huge, just calculated in the sum of fuel consumption. So of course, that's I would lie if I said that wasn't on our short list to try to shape that.
The idea of it in just the automotive, of making vehicles lighter is such a key thing, I think, for us to move forward, particularly with our move, as most countries are, to EVs and electric vehicles. We need to make the technology we've got as efficient as possible. And to help that, we need to make the vehicles as light yet still safe and strong as possible. So I think it's vital that OEMs are talking to companies like yourselves and thinking sort of outside the box. Stop thinking, oh, it's got to be steel. It's got to be this. We've always done it. We have to stop the we've always done it this way thinking, and we have to. And I know companies are doing this. I'm not suggesting that suddenly I've thought this up and no one else has. I know companies are doing this. But we need that accelerating. And I think companies like yourselves will help that and show that it doesn't just have to be carbon fiber. It doesn't just have to be glass fiber. There are new ways of doing things. And I'm fascinated to see how many people get on board with that. And hopefully the likes of yourselves are key to that, that they do get you on board, that they do bring you on. When a panel, I'm going to take us back a couple of steps here because it's one thing I forgot to ask you, but when a panel's being made, say for sake of argument that it's the all-in-one dashboard, how long does that process roughly take?
One of the main potential showstoppers were that we were going to be have a more complex or slower process, and that was something that we just said we have to mitigate this. It has to be as quick as possible. Below 1 minute is the golden rule, and we aimed also to provide a technology that gives lightweight and material reduction without really changing the infrastructure or changing what the tier ones, so the part producers for the OEMs, have to do in their factories. Mm-hmm. So like buying new presses or new robotic cells or whatever. And we have succeeded very well in that. So we changed the tooling slightly, which is very only product defined, so to say. So it's owned by the OEMs. That's the only really big change. The rest is standard compression molded production, cycle times below a minute, and even with what they call back injection, that they actually back inject all the attachment points on the part directly. So it comes out a net chip tool, so to say, a net chip part from the tool.
And then it's ready to go, ready to be installed.
If they, for example, use our aesthetic surface, then you can directly put it into the car. If you need any other covering material, then you have a secondary step.
Yeah. Wow. That's really quick. I thought it would take much longer than that. But yeah, obviously, to keep costs down, you need to be, again, we're talking about efficiencies. You need to create it, build it, and make it and produce it as quickly and at least number of steps as possible, I presume.
Yeah, that's correct. Yeah.
Well, thank you very much for agreeing to come on the Motoring Podcast and explain about what Bcomp does, what you do, and this fascinating products that you guys produce. It's just, like I say, I didn't know about this before this was broached as a possible subject. And then when I read into it, I just absolutely had to have you on the show because I think, as I said, the future, we have to get more efficient in what we do. And part of that, on our vehicles have to be more efficient, and part of that has to be the materials we use. And I just think this is such a fascinating idea to go down natural fibers route. I just think it's brilliant. So thank you so much for coming on the show.
It was really my pleasure, Andrew, and thanks a lot. It was a nice talk.
Thanks once again to Per Mårtenson for coming on the show, and that just leaves me to wrap up and say, if you'd like to get in touch between now and next time, you can hit us up on Twitter via the @Motoring Podcast account. We're there also on Instagram, and we happen to be on the Book of Face too. Or if you would prefer, you can get in touch with us directly via our contact page on the website. That is motoringpodcast.com, the hub of all our activities. We'll be back very soon, but until then, I've been Andrew Clues, and safe motoring.